Well, in the last video, we looked at having an equation or a function that had amplitude, phase shift, vertical shift, and a change in period, and graphing that. We're now going to work backwards. We're going to start with a graph and then work backwards to the equation. Now, you can either come up with a sine or cosine function for these problems. The amplitude, the period, and the phase shift, no, the amplitude, the period, and the vertical shift are all the same, whether you do a sine or a cosine. But when we're working backwards, trying to find the equation, like in this problem and the next one, we're going to be using cosine because it's very easy to find the phase shift for your cosine graph. It's kind of a challenge to find the phase shift for your sine graph. So that's why we're doing cosine. You could technically do either one, but the phase shift for cosine's a lot easier, so that's what we're going to do. So we have our graph, goes up to a height of 2, down to the depth of -4. So we're going to do our max minus min divided by 2 to find our A, which is our amplitude. So our max is 2 minus a -4, so we end up getting 3 after we divide. Now, I always like to go ahead and find D, the vertical shift, right after I find A, because D also uses max and min, but in this case for D, we go max plus min divided by 2. So we'll do our 2 plus our -4 divided by 2, and that gives us -1. So our amplitude is 3, and our D value, our vertical shift, is -1. So now we want to go ahead and look at our period. Your period really goes from this low point to the top point to the low point again, or from this top point to the low point to the top point again. But we only know about one top point and the next low point. Well, if I'm looking at this, going from here all the way down to here is really half of my period. If I figure out that horizontal distance, really all I have to do is double that to get the full period. So I'm going to figure out what that distance is. So 465 minus 195. And I have to double that to get the whole period. Most of the time, you're going to know the top 2 points, and you can just subtract the horizontal distance between them. So we get 540. Now we're going to use peanut butter. Our b value times our period equals our normal period. So we're dealing with degrees up here for our units. So I'm going to be having it equal to 360 degrees. If we were dealing with our x being pi and radians, I would then have 2 pi here. So I'm going to go peanut butter equals 360. We're trying to find our b value. We just figured out our period, which is p, and that was the 540. So I'm going to put 540 there, and that's going to be equal to my normal period of 360. So now I have to get p or b by itself by dividing by 540. 360 over 540 is 2/3. So that's my b value. So that's what I'm going to put right here. Now we need to figure out the phase shift. Now remember, cosine normally starts out at the max. But here our cosine is not having the max right on the axis. It's being slid over 195 degrees. Well, that means that's our phase shift then. To go from what would be the max without any phase shift, we slide over to 195 degrees to get to the max. So our C value is 195. And our phase shift is 195 to the right. So let's take a look at this one. In northern latitudes, around the beginning of the summer, the sun never sets. And then we could graph the data here to the right. So you guys can go ahead and graph that if you want, but we can actually find the equation of our line going through this just by looking at our data. Well, for A and D, you need to have your max and your min. So look at the altitude, find your highest and lowest values. Your lowest here is 6.5, your highest is 40.5. If you look all the way through, all the way down, you have nothing lower than 6.5, you have nothing else higher than 40.5. So those are our max and our min. So I'll go my max of 40.5 minus my min of 6.5, work that out, and I end up getting 17. Then it's easy to find D because it still deals with max and min. So I'll take my 40.5 plus my 6.5 over 2, and that gives me 23.5. Now, in the context of this question here, we're looking at hours in a day, and the sun pretty much from one day to the next day is going to be in a very similar pattern. So how long does it take for it to repeat? Well, that's 24 hours because that's the length of a day. So then we can go ahead and use peanut butter to help us out here. So you could go your period times B equals our normal period. So we're going to go 24 times B equals our normal periods. But to get B by itself, you have to divide by 24. So I'm going to take 360 over 24. That gives me a B value of 15. So once again, my A value was 17. My D value was plus 23.5. I just figured out B right here, and that is 15. Now, the A, the B, and the D are the same for whether you're dealing with sine or cosine. But we're going to look at sine or cosine because it's very easy to find your phase shift. Now, if we did not have phase shift, your maximum would be occurring right at midnight. But it's not occurring at midnight, it's occurring at 1 in the afternoon. Well, how many hours after midnight is that? Well, you know, from midnight to noon is 12, and that's one more, so it's a total of 13 hours. So our period, or our phase shift, is 13, and that's our C value because we have to move it 13 units to be able to get to where the maximum would be.